let we going to who was number 6. Who will report? Andriy Kop want to make
dear
presentation.
colleagues.
Please
Yes,
do
I'm
your
the speaker.
presentation.
Thank you very much for such opportunity to deliver speech a little bit earlier. Okay, so I hope my slides are visible.
Yes,
I may start?
please.
Okay, thank you. Dear colleagues, I'm glad to present our study towards algorithmic and software solution for business process model analysis and correction. It's completed in National Technical University Kharkiv Polytechnic Institute at the Department of Software Engineering and Management Intelligent Technologies by me, Andriy Kop, and my colleagues Dmytro Yulian Fedirko, and Olga Yanvolenko. I will start with the agenda. It introduced the main structure of this study, including introduction and related work, motivation and problem statement, representation formally, business process models, how we evaluate the correctness of process models and do the correction of process models. And also it outlines obtained results and discussion, as well as conclusions and plans for the future work. So as we start, the quality assurance and correctness of process models, especially business process model and notation diagrams, is extremely important to align business and IT to detect mistakes in workflows, to train employees, especially new ones, and guide process improvements. So we have explored several quality analysis techniques used to detect errors in process models. It's used to improve workflow scenarios, to improve general organization performance, and a wide range of related studies are devoted to the methods for BPMN quality evaluation, complexity assessment, correctness analysis and improvement, policy compliance analysis, and other quality features that may affect the efficiency of business process management. And this study therefore aims to contribute to BPM practices, and it proposes the tool for improving the correctness of business process models based on their structural analysis. In general, business process model and notation, or for short BPMN, is the most widely standard for process modeling. It's widely accepted in industry and research field. It offers powerful capabilities for graphically represent complex workflows with being comprehensible for technical and business stakeholders. Recent research made a lot of significant contributions in this field. They propose process model complexity assessment, correction analysis and verification metrics, quality evaluation based on modeling guidelines, and different methods for BPMN model redesign. Existing studies highlight challenges of BPMN models maintenance, and especially their correctness assurance, and the importance of using different design rules to achieve high quality and understandable process models, which is a key of their successful usage. And this study aims to contribute to BPM practices and addresses challenges of process modeling through algorithmic and software solution for both researchers and practitioners, helping them to analyze and correct BPMN diagrams. It includes 4 steps, and I'm going to explain these steps, starting from formal business process model representation. We formally represent the structure of BPMN diagrams using directed labeled graphs, including elements that represent process items like events, activities, gateways, and arcs representing business process flows connecting these elements, and also mapping for text labels marking different elements and flows, like activities can be labeled, for example, verify order, to show which tasks are completed, must be completed in the process, or flows can be labeled like out of stock or in stock to represent different scenarios in the business process. As dealing with the correctness evaluation of business process models, we carefully analyzed existing studies and formulated 6 process modeling recommendations, or rules as we call them. They say that each activity, either task or sub-process, should have one incoming and outgoing flow to avoid some ambiguity. Intermediate events as well should have one incoming and outgoing flows. Gateways should be either splits or joins, like have one incoming and several or 2 outgoing flows, and vice versa for joins, 2 incoming and 1 outgoing flows. Start events should have also single.
You have a last minute, please be shorter.
Yeah. Okay, so in general, yes, we have these rules, and main idea is to sequentially verify invalid elements detected in process model and propose to fix their inefficiencies. We have developed this software based on algorithm, and these rules developed with Python and third-party packages. And as for results, we analyzed 3,700 BPMN models, out of which we successfully processed 99.60% of these models. It was quite reasonable time for processing these models. And as an example, we demonstrate a regional model showing goods dispatch process, and missing workflows as shown with the red elements were restored, and events, tasks, and gateways now properly connected. And we obtained the consistent workflow for this model and other models. And to main conclusion, the data set collected 3,729 models was used, and we processed maximum processing time was 3.18 seconds, and it's indicated reasonable performance. In total, we detected 1,641 invalid BPMN models, out of which 1,283 were improved without solution, and among them 70% were fully corrected according to the process modeling rules we introduced. And in future, we plan to increase the proportion of fixed process models using more formal evolutionary optimization algorithms, and to complete the software, customize it to be used by the end users. Thank you very much for your attention, and I'll be glad to answer the questions.
Thank you very much. Any questions to report? No questions?
No question.
Thank you.
May I start starting my presentation?
Пане Володимир, я ще через 3, ваша черга буде number 6, шостий доповідач, якщо ви не проти.
Окей.
12:25.
Добре.
And now we have a second report. Thank you for Andrei Kop, and the report is interesting. And the second is Vasyl Lytvyn, Victoria Vysotska, Sergey Tyshko, Oleksandr Lavrut, Tetiana Lavrut, Mariia Nazarkevych. Diagnostic method development when weapons characteristics measured. Who will be reported? Report number 2. If no one say, then I will start video, pre-recorded video, if you please. And I will start, and then one moment. It will be maybe only fragment because it's too long video, sorry. We have 10 minutes for report, no? 12, okay, we have. Then I share my screen. You can see, yes. And one moment, please. I share again with sound. Can you see the video?
Morning.
Yes.
Yes.
Okay.
This article, because diagnostic methods development, when weapons characteristics measuring based on spectral analysis for signals phase shift determination. With other Vasyl Lytvyn, Victoria Vysotska, Sergey Tyshko, Oleksandr Lavrut, Tetiana Lavrut, and Mariia Nazarkevych. Actuality. The analysis of known methods that have found wide application in measuring technologies which are designed to control the technical and operation characteristics associated with measurement of phase shift during the development, manufacture, and operation of weapons and military equipment has been carried out. Based in this analysis, it was determined that measuring system designed to determine the phase shift of two harmonic signals have two information transmission channels. The now principles of implementation of measuring systems lead to the fact that a segment impact on the accuracy of the solution of the proposed measuring problem is introduced by component of errors caused by the further symmetry of signal transmission channels as well as internal and external now. Actuality for harmonic signals, such concepts as phase, initial phase shift, and delay time are used as measuring technology. The most complex classification of methods for measuring phase shift of harmonic signals is given in the work. According to the principle of measuring, the method of phaseometry are divided into compensatory methods and methods of converting the phase shift into the values, voltage, time interval, and geometric parameters of oscillographic images of the investigated signal. This method differs for each other technical implementation, complexity, and accuracy. Compensation method are based on the process of balancing compensation, the phase shift delta phi null because 2p between the measuring harmonic signals, that's reduction, the phase shift to 0 by adjustment the phase of one of the signals using an adjustment phase shift shift. Related works. It will denote the angular frequency, south the signs omega equal 2p 2t. Then for the function on the interval minus t c to 2 tc to 2, the Fourier series, the form phi vt equal annual to 2, and sum AK cosinus BK sinus KT. The dispersion is now method include a significant impact on the accuracy of measuring the further shift of the error component, which is caused by the further asymmetry of the signal transmission channel. The percentage of two channels for conduction analogous to digital conversation is input signal, which lead to the need for modal synchronization of the frequency of clock generations for each of the channels. Significant impact on the accuracy of external and internal noise measurement, non-linear nature of the scale. MoDaST model present the determination of the phase shift is the greatest interest in phasiometry. Phase shift refers to the models of the difference between initial phase of two harmonic signals of the same frequency. As a rule, the measurement of phase shifts of signals is based on the model of the harmonic signal, which is specific without changing in its parameters over an infinite time interval. This model is ideal, and in practice, a model with a finite time window is used that is measurements are carried out on finite time interval. A vector diagram for determining the value of the initial phase of the phase harmonics of the signal was presented on this picture. The vector diagram for determining the value of the initial phase phi of the first harmonic of the signal U. U is sum UM2X. To value UM for UM equal 1 volt, UM presented with then data and structural diagram for the transformation of the signal into into the signal with on picture. The model works in mathematics program. Experiments, results, and discussions with figure time diagram of signal and U1 strich and U2 strich and U sum strich, the value of the delta phi equal 0, and diagram the signal O1 with O1 T and U2 T and other U with T at the value of phi equal 0.9. And as a slide with time diagrams of signal U1 T and U2 T and other U at value delta phi equal 1.2 RAP with diagram on the picture, and conclusions. Analysis of the known principles of measuring phase shifts was carried out. The analysis showed that a significant contribution to the final measurement error of phase shifts is made by the component caused by phase asymmetry of signal transmissions channel and the influence of experiment and internal noise as an alternative approach to determining the phase shift it is proposed.
Sorry, maybe I stop this presentation. We have left 1 minute. And you can read all this conclusion. And we have no possibility to ask question to reporter. Therefore, thank you for this submitted presentation. If you have no questions to me, we are going to next presentation. Okay. I must be strict with timeline, sorry. And now presentation number 3 is Olexander Belej, Yulian Fedirko, Oleksandr Markelov, ensuring accuracy of personal data processed in blockchain systems.
Hello.
You can share your screen.
Okay. Can you see?
Yes.
Okay. Our setting we in blockchain sphere. Blockchain consists of the following basic elements: useful service data from the previous block in the chain. Useful data can be any information that need distributed storage. The general meaning of smart contracts comes from the idea of smart assets. Smart contracts are a method of conducting transaction is a decentralized ledger based on the user of cryptocurrencies and smart assets to sign agreements through blockchain technology. If the owner of the asset does, the exchange takes place after notification, and ownership automatically pass from the finance company to the individual after all loans are paid off. Proceed from the point of view judicial practice, high-quality contract drafting, and the introducing of automatic enforcement mechanisms can significantly reduce the number of disputes. The combined use of smart assets and smart contracts can create a lending system that uses both smart assets as collateral, thereby reducing the cost of insurance against fraud and both and making lending safer and more profitable. Distance since the future of smart contracts is that there is no need for trust between participants. Smart contracts and executed automatically using code running on blockchain technology, leaving no room for the human factor. However, the use of smart contracts today requires a strict regulatory framework to regulate the procedure for fulfilling contractual obligations. It's assumed that personal data should be processed in a blockchain system at least during the entire life cycle of the subject of personal data. During the entire process of personal data processing, their safety, confidentiality, availability, integrity, and reliability should be ensured. Currently, the challenge of creation of a blockchain system architecture that's free from the main sets associated with blockchain system, including ensuring the reliability of the processed data. Therefore, the construction of a protection decentralized registry of personal data, DRPD, in next slide boils down to solving the following tasks. First, at the time the composition of a black hole, it must be processed in DRPD, define the all DRPD architecture, the time, the order of data storage, the time mechanism for reaching consensus, including procedures for providing rewards to users to ensure the operation of the DRPD, and procedure for automatic assessment of the risks of processing unreliable personal data. Select the hash function calculation method, the time, the general sequence of development of the DRPD. And in the first further, the recommended report personal data, and we can see the holistic approach of the decentralized registry of personal data to protection human resource. And we can see process transformation personal data to other blocks of our mechanism and other method for realization our idea. Based on the analysis of the existing requirement, and method of ensuring data security, the relevance of development method of ensuring data security during the processing in blockchain system by using artificial neural networks has been confirmed. A method of ensuring the reliability of personal data processed in blockchain system has been developed. A part of the development of this method, the category of method for ensuring data reliability for expanded by using artificial neural network to identify unreliable personal data when they are entered into the blockchain. A method of analyzing this authorization behavior of information system users has been developed. A part of development of this method, user behavior was formalized, and the possibility of detection anomalies in user behavior using artificial neural networks was demonstrated. We can see the block structure of various chains in method taken into account the purpose and composition of the personal data from DRPD has several independent private blockchains. And in figure C, we can see general hierarchy of decentralized registry of personal data, and we can see as a block of our blockchain for contracts, for smart contract. Due to the specificity of the thematic field, doesn't publish new blogs every day, but mainly contains information about additional professional education received. But the fall and the spring will be the session when new quarters with information about secondary and higher proposal for number and frequency of creation of new blocks during will appear. And the table 1, we have a proposal for number and frequency of creation new blocks. And this data we can transformation in next scheme. In these schemes, check the general register data in our system for smart contract. Reward method and their definition require careful study and are beyond the scope of this study, and table 2 provide general example of possible reward values to demonstrate the general principle of rewarding using. For said theory, we can be used to demonstrate the value of rewards, and we can see these values for our example and 2 variants in discussions. The general graph of our artificial neural network for determining of the reliability of personal data we can present in this scheme. And we can see the depends on the degree of connection between the verification object and the consensus node and favorable conditions for collusion. The relationships between the level of participation and the probability of mutual confirmation of the consortium Internet of Things we can see in these graphs, and we can see the level participant and the probability mutual confirmation. That depends on the ability of verification object and the consensus node, and the probability of collusion we can see on this graph is the dependence. And the result displayed by neural network at the initial stage of training are shown in this table, and we can see the initial state for neural network training. After completing the training of the external neural network, showing result in this table, and we can see parameter for as a meaning for dependent parameter of our training neural network. The most common scenario for the centralized systems based on blockchain technology seems to be the user of interaction paths with complex structures that allow network segments to be connected in this series and parallel. And we have another components. The first segment includes a parallel connection of the communication 3 and 2 segment, and the second segment is present connection to the 3, and the result is 4 segment. In figure 10, we have a combination of elements, fragment 1, 2, and 3, connected in third, forming parallel for segment 4, and the result we can see fragment 5. Fragment 5 and 6 are connected to the segment 7, and 7 is the result of our formation algorithm of smart contract. The category of data reliability methods is expanding due to the use of artificial neural networks to identify unreliable personal data when entered into blockchain systems. The reliability of personal data processing in blockchain systems can be ensured using the proposed method, the single-leveled cloud platform, or at the country level, and next method as part of ensuring compliance with the requirements for monitoring incorrect user actions when entering personal data. This method is different from known methods by the unique architecture of the information system of personal data, and differs from known methods in that is user conceptually new consensus approach that involves an automated assessment of the risks in implementing unreliable material handling, the theory of artificial neural network, and the theory of fusion sets. Thus, the task proposed in the article has been solved to develop a method for ensuring the ability of personal data processed in blockchain system, and when the data enters the blockchain system, its reliability will be automatically evaluated. Thank you for your attention. Question, please.
Thank you, reporter. Maybe somebody have questions to reporter about. Maybe I have one question. Whether such your system could be applied in which kind of personal data you are processed?
Okay, thank you for question. We have as a kind for our training neural network depends in this graph connection between the verification object and the consensus node. and were favorable conditions for collusion. In this graph, we can see the level of participant and the probability of mutual confirmation of the conspiracy Internet of Things. In this graph, we can see the verification object and the consensus node and the probability of collusion. This good?
Yes, yes, I understand, but all this system of processing personal data
Yes.
is used for some reasons in some special information systems. Which kind of personal data
Yes.
should process this system?
Okay.
Some kind of smart contracts, I don't know.
This personal data is verification object, consensus node. In this data about users of smart contract data as personal data about users, number of insurance, number data of maybe name, users, and signature.
Okay, well, some set of data. Thank you. Many, maybe somebody else, no questions.
Okay.
Then we are going, thank you, and we are going to next report. And report number 4, Maksym Vakulenko, Vadym Slyusar, approach to reverse dictionary task based on automatic smart subword segmentation of Ukrainian physical text.
Okay, hello everyone. My name today is Olga Shelest. Please don't be confused.
Yes.
My name is Maksym Vakulenko. Can you see my screen?
Yes, we see.
Okay. So, an approach to the reverse dictionary task based on automatic smart subword segmentation of Ukrainian physical texts. A significant aspect of natural language processing tasks involves the generation or prediction of text or words. Reverse dictionaries hold promise in this domain, where machine-generated lexical units are proposed based on their definitions. Within this framework, employing subwords as fundamental linguistic units offers notable advantages over conventional methods. Compared to approaches using complete words as the smallest units, utilizing subwords circumvents issues associated with unseen words, allowing for the construction of new words using an existing subword vocabulary. Unlike character-based approaches, subword employment maintains a connection to underlying semantics. It is important to highlight that the prevalent by-pair encoding method for word segmentation, grounded in mathematical statistics, exhibits several drawbacks. Among these, the most unpleasant is its tendency to erroneously segment compound words like electron-neutral as electron-neutral, or so, instead of electro-neutral. At the same time, one of the major difficulties in the terminology work is conditioned by the need to process huge amounts of terminological data, which motivates their automated processing. In particular, an important part of terminology management is the prescriptive step, where the prescribed or recommended term should be chosen or created on the basis of its definition. In this sense, the process of attributing designations to concepts in terminology science corresponds to reverse dictionary task in NLP. Such formulation of terminological and more generally linguistic tasks in terms of machine algorithm contributes to linguistic competency of an artificial personality with artificial intelligence that manifests the person's ability for human-like thinking, effective lingual communication, and the so-called accurate report. The last is considered in turn a significant sign of consciousness in mammals. The segmentation of Ukrainian tasks relies on the set of Ukrainian morphemes.
I'm afraid it's not actual slide now.
It is the third slide. It's okay.
Okay, sorry.
A curated collection comprising 2,000 Ukrainian roots, encompassing both commonly used and domain-specific units, has been manually introduced. Our initial approach involves the utilization of individual subwords. The subwords exhibit significant homonymy, wherein the same combination of letters may occur in different parts of distinct words with varying meanings. We anticipate that incorporating individualized subwording into the neural network will yield average sense embeddings similar to those at the word level. Then, as an analog to contextual embedding models for words, we elaborate on a vocabulary of combined subwords, wherein each sense corresponds to a combination of elementary subwords, if applicable. We hypothesize that this second approach will yield a more specific neural network output. The definitions and explanations of terms are drawn from the explanatory dictionary on physics, which, after the removal of in-text cross-references, comprises over 6,000 distinct entries. The resulting subword vocabulary contain approximately 28,000 units each. The free Microsoft transliteration tool has been utilized to facilitate automatic text segmentation based on rules embodying both approaches. To range the predicted terms according to their applicability, we suggest using the up-term criteria formulated in a machine-friendly manner: exactness, essentiality, plainness, derivativity, good sound, systemic feature, organic feature, compatibility, unambiguity, nominativity, and brevity. Here is an example of the subworded text. The full text of explanatory dictionary on physics, subworded into simple and combined subwords, is available on GitHub here. The practical implementation of the proposed approach consists, first of all, in training of embeddings for Ukrainian subwords. At the same time, it is advisable to consider the combination of the proposed approach to segmentation based on morphemes with known methods of tokenization and vector embedding of whole words. This can significantly improve the performance of NLP models, including those designed for reverse dictionary tasks. Tuning the architecture of the language model covers two main aspects: the inclusion of morphological information in the input layer of the language model and the corresponding adaptation of the attention mechanism. The learning strategy of LLM-modified architecture is based on joint learning on morphological and semantic tasks. An advanced option for merging different LLMs, which has been intensively developing recently, is to combine their architectures using a special match kit framework. Its feature is the possibility to obtain the resulting model of the same size and the same number of parameters as in the models that were subjected to the merging procedure. The list of the main methods of this type is presented here. This figure illustrates the process of combining 4 pre-trained language models into one using the JRTICE combined method. In this way, for example, a language model of a physical technical orientation can be implemented. An alternative option for combining models with the embedding of word vectors and subword vectors is to use the switched mixture of experts, MOE. The main idea behind MOE is to distribute input data between different expert models based on their specialization. After processing the input data by several selected experts, the results of their work are combined using a switch that determines the weight of each expert for the final output of the model. At the same time, the rest of the experts are not involved. That saves computing cost and allows reducing the requirements for available hardware resources. Combining input from experts specializing in different levels of linguistic analysis can lead to a deeper and more comprehensive understanding of a text. Conclusion. So we have introduced a novel method for subword segmentation essential for the pre-processing phase of reverse dictionary tasks and other natural language processing challenges, thereby embodying the principles of terminology science within a machine learning framework. We also have established criteria for term suitability in a format compatible with machine processing and discussed possible ways to carry out machine learning to obtain on the basis of a reverse dictionary. The resulting subworded text mitigate errors commonly encountered in a widely used byte pair encoding algorithm, which relies solely on mathematical statistics. By employing symptomatic statistical and analytical techniques from terminology science within machine learning, we take a significant step towards executing various terminological tasks intelligently, effectively imparting human-like thinking to AI systems. Furthermore, the neural network trained to autonomously generate terms for novel concepts holds the potential to evolve into advanced AI technology capable of handling all terminological work. Thank you for your attention.
Thank you very much. Please, questions from the auditorium. It's interesting, such kind of building embeddings for part of words, yes, and it's related to Ukrainian language. Other like languages with parts of suffixes and prefixes and so on, or it is also connects with languages like English and so on.
Yeah, generally speaking, we can use these techniques to any other language. For example, I started this activity while being at Bratislava, and I discussed this point to local specialists. They disclosed a great secret that they early tried the similar task for the Slovak languages, and they had no success because of this problem of new words. And when they realized that there is another approach with which uses subwords, they understood that this language has a great potential, not only for Ukrainian, but also for other languages.
Yeah, it's interesting. Yeah. But you should build your own LLM, long language model, and software, not software, but hardware, it quite costly techniques needed.
Yes, we understand that this is not an easy task. So we are hoping that with Vadym and with perhaps with other specialists, we'll be able to do so, because it is required from the side of linguistics.
Yeah, but I mean computer resources needed, huge resources to build own LLM, rebuild
Yes.
model.
Yes, I understand. I understand this is a real challenge for us, but we have plans to overcome this difficulty.
Yeah, I wish you success. Thank you very much.
Thank you.
Interesting report. And we are going to next report number 5, and Olexander Oletsky maybe already wait for have a word.
Yes, I am sharing my screen.
Please.
Well, do you see my screen?
Yes. Please. Okay.
Well, I would like to represent the report an approach to modeling elections in bipartisan democracies on the basis of the state probability of action model. The authors are Dmytro Dosyn and Oleksiy Oletsky. I am Oleksiy Oletsky. Well, this study is devoted to social modeling of voting on elections, which normally take part in bipartisan democracies, in democratic societies, including bipartisan democracies. And this modeling, or maybe even simulation, is carried out on the basis of the model state probability of action. This is an agent-oriented model which focuses on behavioral aspects. And this is also a probabilistic model of uncertain decisions aimed at calculating probabilities of alternatives to be chosen. And what we are going to do is to combine the model suggested some earlier with the analytic hierarchy process suggested by Saati. The model itself, it involves the basic version of the model involves some states. Each state is connected to probabilities of choosing a certain alternative, and it is represented by the matrix, row of which correspond to the existing states. And a part of this, we should specify a vector of input probabilities of that an agent, each probability is the probability that an agent is being in a certain state in the moment. And this vector reflects opinions of agents, of voters. And in such denoting needed final probabilities for alternatives to be chosen can be calculated by vector matrix multiplying. This is a basic model, and it is important to get input probabilities because they apparently reflect opinions of agents. They can change, and this means changing of agents' opinions. These probabilities can be specified directly, but it is very important to get these probabilities from a Markov chain of transition across the states. And this should definitely entrench behavioral simulations. And the matrix. Now we are combining two approaches to apply the idea of pairwise comparisons within which each state is connected to a certain grade of preference, and to consider decisiveness of agents. And we are suggested the parameterized model for getting such a matrix state probability of choice. We should introduce grades of preference numbering Q. As usual, they may have clear linguistic meaning. For example, alternatives are equal, or one alternative is slightly better than another, as usual in the analytic hierarchy process. But we don't use the standard scale suggested by Sati. Instead, we are using so-called transitive scale. And this results that the value ascribed to a case grade of preference is tau in power k. And the last but very not least parameter stands for decisiveness of agents, and then we get elements of the matrix by such a formula. What is special in applying this model to bipartisan voting? First of all, number alternative is 2, because there are only 2 leading parties. It is a society, and there always are agents of influence who are trying to affect decisions made by other agents or voters. First of all, by information influence. And in this context, situations of equilibrium are of great importance, because this is only a situation of equilibrium when alternatives are equal chances to be chosen. Otherwise, the sliced advantage of an alternative shall be sufficient for its victory. And this is important for bipartisan voting, because so that parties change each other in turn, situations of equilibrium should be either permanent or happen repeatedly. This was the basic model. The matter can be more complicated. First of all, the basic model is about a simple decision, but the decision depends on different factors, and these factors might be interconnected, and such connections can be regarded within a network of models where each model is connected to any factor. But now we are applying a more simple hierarchical approach, and we are suggesting the two-level multi-criteria model, when decisions in the voting depend on different criteria, alternatives are compared by, and then we introduce two levels of models. First of them, top level of model is connected to final decision voting, and initial bottom level is connected to criteria, comparison by special criteria, and transition between the levels is specified by the transitional matrix. And instead of top-level input probabilities, we should specify bottom-level input probabilities. And we see that this is in some measure looks like the AHP. And to get final probabilities, we should obtain separate vectors by each criteria to combine them with the given or calculated weighting coefficients, and then get the resulting probabilities. And this can be written in a simpler way. And now we can formulate and to prove the sufficient condition for equilibrium, which is very important. If both matrices which we figure in this formula are centrosymmetric, and if vector weighting criteria is a symmetric vector, then equilibrium between two alternatives holds. This statement can be reformulated for a simple case if transition matrices for all criteria are equal, which can be considered as more or less typical. And then if all of these matrices are centrosymmetric and lambda, the vector of weighting criteria, is symmetric, then equilibrium between alternatives holds. We are delivering an illustrative example in our paper. Let there be an imaginary country, and let two leading candidates compete to become the president of this country. And we assume that they are compared by the following criteria. Probably, in reality, such criteria might be very different, but this example is the very illustrative one. We think there is no need to give all calculations just in the presentation. They are given in the paper. But what we do, first of all, we illustrate the situation of equilibrium between alternatives by picking out proper parameters. And then we are showcasing how this equilibrium can be broken by influences in some parameters, input criteria probabilities, weights of criteria, and degrees of decisiveness. What we are going to do next? First of all, found conditions of an equilibrium between alternatives are sufficient only, but they are not necessary. And it appears very important to find necessary conditions. It is possible, but such conditions should be found. What we consider to be very important is to implement different models of influence within social networks to combine the model with different methods describing influence in social networks, which is very important for modern society. And last but very not least is the game approach, because we are considering the situation when different agents try to turn the situation into desired direction, and they have opposite goals. And then a game arises, and we should to develop a game approach. Thank you for your attention. We are ready to answer your questions.
Thank you very much, the reporter. And maybe somebody wants to have questions. Very interesting report, but formally participating, therefore, no questions from me.
Maybe you can ask some other questions later. It is in progress.
Yes. Yeah. Okay.
Well,
Then thank you again. And we are already going to next report from Volodymyr Riznyk. You
Thank
have
you.
a voice here.
Our report concerns.
First of all, share your screen. Please try again. Поширити екран.
Поширити екран.
Let I show you how to do this. I will share my screen and try to show you where is it, this button. You see my screen and you see this button, new share. Can you see? Below, внизу зелена кнопка. Якби я бачив ваш екран, я би підказав, а так мені важко зорієнтуватися, куди ви дивитесь.
Зараз, ну, я вибачаюсь, я шукаю звичайний, далі дивимося сортування слайдів.
Ні, не сортування слайдів. Ви перейдіть на цей Zoom. Верніться в Zoom.
Zoom, ага, так.
В Zoom є внизу рядочок з командами. Лівий крайня, там мікрофон.
Аудіо. Ні, ага. Share, так? Share.
Share screen, так. Натисніть.
Оце. Так, натиснув, share.
О, і тепер виберіть той екран, який ви хочете показувати нам. Там має
Так.
бути вибір у вас. О, бачите.
I see.
We
Оце
see.
видно зараз?
Yes, видно.
Yes?
Yes. Good.
May I start give our report? Thank you. Our report concerns multi-criteria decision making, supporting with optimized multifactor combinatory analysis by Volodymyr Riznyk and Roman Sydorenko with Polytechnic National University Computer-Aided Control System Department. Representation and definitions. The multiplied system supporting problem can be represented in a criterion space or the decision space. Alternatively, if different criteria are combined by a weight linear function, it is also possible to represent the problem in the weight space. Below are the demonstrations of the criterion and weight spaces, as well as some formal definitions. Modern method of multi-criteria decision making, as well as multi-criteria decision analysis, are the most accurate methods of decision making, and they can be known as a revolution in this field. The next, you can see a list of application fields and appropriate examples of the application focus. On the left column, we can see application fields, and on the right, examples of the application focus. Application field, education, contextual learning, modeling in the personalized and ubiquitous learning and electronic learning. The career and job, occupational stressors among the firefighters, personnel selection problems and job choice. The supply chain management, supporting sustainable supply selection, green supplier evaluation and selection, civil engineering, flood disaster risk analysis, finance and our economics, project portfolio management, energy sector, ranking renewable energy sources, techniques for energy policy, energy, engineering and production, engineering, material selection for optimal design, optimum process parameters, organization and corporates, the system selection process in enterprises, corporate sustainability and transportation, urban passenger transport systems, integrated transport systems, and health also, and so on. The next file, you can see so-called ideal ring bundles definition and stage ring sequence of nature number, which the set of all sums of connective terms in the ring sequence form numbers from 1 to sum of all sequence is named ideal ring bundle, each number occurring exactly 1. The graphical presentation of this model you can see. Next, the next. Application of ideal ring bundles for optimal multifactor planning of experiments. An optimal combinatorial plan of experiments is known and can be developed using the so-called Latin square and their complete sets. Or a Latin square of order P forms matrix, which matrix P multiplied P, which contains each symbol in each row and column exactly once. And two Latin squares of order P are called mutual orthogonal Latin squares. Next. The next, you can see the optimal combinatorial measurement plan based on elements can be generated using the next calculating actions. You can see this form based on n sequences of numbers of the IRB of built and in matrix of numerical symbols. P for numbering the rows of Latin squares. And the next, you can see build a supporting matrix C for numbering columns of Latin squares. The next calculating actions is connected with configuration for configuration the Latin squares. In this slide, you can see synthesis of optimal multifactor plans of experiments. As an example of the implementation of the above algorithm, we construct a system of pair wise of orthogonal Latin squares based on the IRB 1, 3, 2, 5, where we can see it, a number is given in the slide. The next slide is a set C for numeration of Latin square column. And this we can see the set for finding the complete set of Latin square for the first, for constructing the first Latin square. The next, we can see the set for finding the complete set of Latin square for the second Latin square. And analogy and the same way, we can construct the set for finding the complete set of Latin square for the third Latin square. On this slide, we can see the set of Latin square, pairs Latin square, according to the constructed according to the coordinates of the sets, column and row, as you in this slide. These squares form a complete set, all family of the matrix, to design 5 optimal measure plan. Each factor can be have 4 levels. And next, you can see the optimal plan of experiments with 5 influence factors, A, B, C, D, E. You can see the number of experiments. It can be, must be 16 experiments, and in column you can see level of the each factor. For example, results of experiments can, by result of experiment, we can see each criterion from X to Z or more criteria is of given results, and we can obtain 10 in this experiment, which give us the maximum criterion of chosen criteria from X, from Y, from Z, or combination of the criterion. In conclusion, as conclusion, we can say that application of IRBs in the fuzzy decision analysis provides for the minimizing of experiments while maintaining or validity of the analysis. It is possible to use a simple algorithm to design the optimal multifactor plan of experiments in matrix form. The proposed algorithm can be well applicable for analysis of the influence of the lot of physical parameters, as well as some other factors on the behavior of the analysis fuzzy object or its model. This approach makes it possible to provide sufficiently less of computing fuzzy decision analysis while maintaining on validity of the analysis. The application of ideal ring bundles provides for finding optimal solution problems by reducing the volume of the experiments in fuzzy decision analysis while maintaining on the validity of the analysis. It is possible to use a simple algorithm to design of optimized multi-factor combinatory analysis. Thank you. Question, please.
Thank you very much, dear Volodymyr. Maybe somebody have a question to reporter, Professor Riznyk. No. We here listen about 5 criteria, only 5. When we have 10 criteria, for example, how this approach could be expanded much more criteria.
It is as illustrative. This is illustrative example, not concrete problem, but illustrative only. So unfortunately.
Understand. Yeah, but this ideal ring is can include more points.
And due to property of very well property of model ring like model, you can construct this fuzzy decision analysis and the plans minimize of the due these models we can obtain solution of this problem, these problems.
Yeah. To my pity, your report was included in this section, but Mikhail Emerich is expert in this multi-criterial decision-making problem. He's maybe he should review your report. Maybe it will be interesting for him for help of another section, because it's connects.
Thank you. Thank you very much.
Thank you. Thank you for your report. It's interesting. And
I would like to add that this method maybe is well appreciable and is profiting for very class of solution, optimal solution for wide classes of technological problems.
Yeah, I understand, of course. Even when I want to choose car to buy a car, how much criteria and
how much criteria, of course.
Selecting, even select.
Yes.
Yeah.
Thank you.
Thank you. And now we have a coffee break. Sorry, 20 minutes coffee break up to 12 by Central European Summer Time and 1 o'clock p.m. in Ukraine. Okay, then 20 minutes break. Thank you for participation. Please connect after the break.